Let's talk about the format of an object and some of the differences between a file system. Okay, in Swarm, it's using just standard JBOD servers. It doesn't need anything special, it doesn't need any RAID controllers. And the way that Swarm manages disks or otherwise is it just sees it as a volume. And that volume to it is a big, long tape, essentially, of data. And we write to this volume in a sequential fashion, and we clean it up as if it's a big circular cube. So when we write an object to disk, we don't actually have any inodes, we don't have any information. The only thing we have at the beginning is a journal that allows you to have what's on there, what's changed, what's going on with it, okay? And so what happens is you lay your object down on disk, and your object consists of system metadata, and then after the system metadata comes the user metadata, and then after that comes the data, and between all of those are digests, and then a final digest. And these are all used during the health processing cycle to make sure the data is all intact. So there's actually what we call a health processor in the background. It goes through and it checks your data and makes sure it's okay, and it walks through the disk periodically doing this, so you can't get bit rot. And in fact, one of the advantages of us over all of our competitors with respect to EC is that we can identify a single EC slice that's out and replace it immediately. So for the same protection scheme, we can actually get a higher level of nines because we're doing active recovery. For example, if we break out and look at each individual element of a data file that maybe, say, is a video, okay? The system metadata is going to contain information about its create date, how big it is, some information about, where it is in the system, the other copies of it, like hints of it, so it's going to tell it where it is. It's going to have some markers that say whether it's actually been fed or replicated to something. So there's system level metadata that is looked at by Swarm itself to manage the object and its state. Then there's and in fact in this there can be life point policies. A policy might be something like you can live undeletable for 7 years, 7 more years you're deletable, and after 15 years you go away. Or for 3 years store 3 reps, and after 3 years store it as erasure coded 5.2, okay? The user metadata is whatever you want. The user metadata, you may say, this was police car number 2, video camera 1 in the car, officer so and so forth driving the car, GPS locations this, what coordinates or otherwise. And so now you've got all this metadata, and oh, by the way, both these sets of metadata make it into the search engine, okay? And then the data itself would be the video. And the video would be in its standard format. You would literally be able to read this data through a standard streaming protocol on any of your PCs, and it would just be able to read it because it would be HTTP and all the streamers would just work with it, okay? And then at the end, you have a digest of, so what are the digests? The digests are MD5 hashes or other hashes that we can use that actually hash all the system metadata so that you can verify that's correct when you read the object. Then it does the same thing for all the user metadata so that when you read that you know it's correct. And it does the same thing for the data so that you can actually individually find errors even within an object so that you can fix those errors if you find them. And then there's a total digest which actually takes it all and just makes sure that you can quickly check that everything's intact. And that's what an object is within Swarm. And when it's stored on this disk, there's actually an entry in here for an index entry that says, its ID basically, and that it's stored on this volume. And when you actually load a volume into Swarm, those IDs are all loaded in an in-memory setup so that the system can find it without ever hitting the disk. So one of the big benefits of this object storage system over file systems is that you never actually have an IOP until you start reading the object. And any node in the cluster can find it for you using a particular market algorithm that we have that uses heuristics and this index to find the object without ever hitting the disk. Okay? And as a result of not having the overhead of an inode system and a file system on here where you may lay these out, all that space that would have been taken up by the file system, and oh, by the way, the extra space you need for performance, we can eliminate all that and use the disk much more efficiently. So we're much more efficient in disk utilization than a file system is. And in general, we don't have that problem of having to hit where the inodes are, which causes hotspots on disk, which causes disk wear, which increases the risk of corruption and data loss. So we reduce the risk of losing your data by storing the data in a format that doesn't require additional on-disk infrastructure, and it doesn't have to go through additional software layers which can actually potentially corrupt that information.